Geometry Products video training. We're going to talk today about out of range. Calibration points where you always come up out of range. Now, what we have on this system here is conductivity sensors. There is one pH and ORP, they're really the only two that vary, and we also have a little bit on that one. But the linear scales, conductivity, boilers, electrode lists, all those things, you'll see that they are very, very linear. You know, you've got zeros to max, where pH is a little bit different. It goes plus numbers back to zero to minus numbers. So you'll see in that video. But the out of range means is that the system can't do the adjustment from what it thinks it is, or the raw value, to what you're telling it is. Now, inputs, conductivity, and if we, instead of hitting the maintenance, we hit raw value, we see it says 477. The machine can do at least a 1.5 times. So half of that, 225, plus that, it'll go up about 600, 700, 625. So you see what I mean? It knows, and this is, you can't change it. It thinks that it's 476. I can only do 1.5 times plus or minus from what it thinks it is, okay? The first thing you should do when you get an out of range calibration, I want you to make sure when you do a calibration, the first thing that you've done is you removed it from the system. You take away a lot of variables there, and we can discuss that when you call, or if you need to. You take the variables away, and then make sure, based on the wiring label that's on there, that your wiring is correct, okay? And that your maintenance, of course, is correct. This is a C-con, and then you have all those things, go back through the video training for setting up a C-con sensor. So make sure your setup is correct, make sure your wiring is correct, make sure your sensor is out of the system and into a beaker, okay? If you pull it out and you can get it to do a calibration here, it's in the system, out of range. There's some electrical interference or something going on in that system. You've isolated it from all those things. So we're gonna get it, we're gonna put it on here, and we're still getting out of range. This is what we're gonna talk about. It's 1.5 times what it thinks the raw value is. This is just city water for me, okay, here in Brad. What I've done, I got my little test tee, and I've got some 1400 microsiemens. And you can see that the machine thinks it's about 1100, okay? So if I went to do a calibration, which is that button right there, 1 point buffer, disable the controls, and I'm going to tell it it's 1413. Now, if it wasn't 1.5 times what it believed it was 1180, it would never do the calibration. Here it is, it's within that 1.5 times, and it should give me a stabilization. Please let it stabilize itself. If you hit the check, you can force a stabilization. That's going to depend on where you're at. It's not going to give you a true reading. You want to let the machine do the calibration itself. And it does take a little while, but we want it right. There we go. Okay, so yes, say the calibration results. Good. Okay, now we're going to go back and look at that raw value. It says it is 1413, but we're going to go pan down. Raw value is 1250. So that's the adjustment it makes from what it believes it is to what you're telling it is. That's when we do a calibration. Okay, so we're going to drop it off here back into the regulars. That was an open ear calibration. You can see that it reads like a 1 or a 0, and it says 480. That's what it believes that it is. Now, if we took a test run, it probably isn't 488, but it's going to be close. It's got to be within the 1.5 times. Okay.